हेलो एवरीवन, चलिए स्टार्ट करते हैं हमारा नेक्स्ट लेक्चर। हमारा सीरीज जो शुरू था वो था थ्योरेटिकल लेक्चर सीरीज ऑन द गेट ड्राइवर। इसके पहले हमने बात की थी दैट आईजीबीटी और मॉसफेट टर्न ऑन एंड टर्न ऑफ कैसे होता है, व्हाट आर द वोल्टेज एंड करंट रिक्वायरमेंट्स फॉर द टर्न ऑन एंड टर्न ऑफ द दिस हाई पावर इलेक्ट्रॉनिक्स डिवाइसेस। देन आज देखेंगे हम क्या क्या रिक्वायरमेंट रहती है फॉर द गेट ड्राइवर सर्किट। सो फर्स्ट इज आइसोलेशन। सो आइसोलेशन दो टाइप के रहते हैं, आइदर इट शुड बी मैग्नेटिकली आइसोलेटेड और ऑप्टिकली आइसोलेटेड। मैग्नेटिकली आइसोलेशन का मीनिंग है ट्रांसफॉर्मर बेस्ड आइसोलेशन, बट disadvantage is that transformer based isolations are generally bulky. Some inductor or inductance interference is also occur during this isolation, so generally it is avoided. So next best option is optical isolation. Next requirement is that gate driver should possess the level shifting, then there should be also the floating power supply. उसके बाद रहना चाहिए हाई इनपुट इम्पिडेंस। देन गेट ड्राइवर शुड सेटिस्फाई द पावर रिक्वायरमेंट। जो पावर चाहिए हमें टू टर्न ऑन एंड टर्न ऑफ द आईजीबीटी, वो भी कहाँ से आनी चाहिए? फ्रॉम द गेट ड्राइवर सर्किट। स्लोली देखते हैं कैसे आता है। नेक्स्ट, what is the optical isolation? In this lecture we will basically focus on the optical isolation only. Generally optical isolation ही यूज होता है हर तरफ। Optical isolation is an electronic component that transfers the electrical signals between two isolated circuit by using the light. So ये हमने 12th या 11th में पढ़ा था, what are the photodiode और photo transistors. So यही कंसेप्ट यूज करके हमने ऑप्टिकल आइसोलेशन रेडी किया है। सो देयर कैन बी ऑप्टोकपलर्स, फोटोकपलर्स और ऑप्टिकल आइसोलेटर्स. So commercially available optical isolator should withstand the input-output voltage up to 10 kV and voltage transients at a speed of 25 kilovolt per microsecond. चलिए इस लाइन को समझते हैं by using one graph. So ये ग्राफ में हम देख सकते हैं that voltage increases from 0 kV to approximately 2.5 kV at a very short period of, for example, 0.1 microseconds. So ये देख सकते हैं, this is the graph of microseconds. There is the high dB by dt. High dB by dt is around 25 kilovolt per microsecond. Means 2.5 kilovolt per 0.1 microsecond का ही कन्वर्जन किया हमने 25 kilovolt per microsecond. So it is a high voltage optical isolation. So optical isolators should withstand this 2.5 kilovolt. Generally this is almost lower than 10 किलोवोल्ट्स कैपेबिलिटी। जनरली कैपेबिलिटी कितनी होती है? 10 किलोवोल्ट्स की। सो जो ग्राफ दिया है, जो ग्राफ हमने देखा है, दैट इज ओनली अप टू 2.5। सो आई थिंक इसका मीनिंग समझ में आ गया। ओके, सो जनरली इनपुट आउटपुट वोल्टेजेस आर इनपुट वोल्टेज कुड विथस्टैंड अप टू 10 किलोवोल्ट्स ऑप्टिकल आइसोलेशन। सो प्रैक्टिकली पावर इलेक्ट्रॉनिक्स कन्वर्टर्स में हम जब स्विचिंग होती है और सडन टर्न ऑन एंड टर्न ऑफ द इलेक्ट्रॉनिक स्विचेस होती है, सो दिस काइंड ऑफ वोल्टेज ग्राफ और वोल्टेज स्पाइक्स यू कैन सी। फॉर एग्जांपल सडनली एसएमपीएस एंड इन्वर्टर्स में जब हम स्विचेस और आईजीबीटी का फास्ट स्विचिंग करते हैं, जनरली तब ये फिनोमिनन देखा जाता है। सो दिस शुड नॉट बी ट्रांसमिटेड एट द आउटपुट, सो वी हैव टू ऑप्टिकली आइसोलेट इट फ्रॉम द आउटपुट so that the output circuitry should not damage due to this sudden spike in the voltage. Next, so these are the photocouplers, optocouplers, or optical isolation. So this is the phototransistor. Phototransistor is there, and here there is a photodiode. Means transistors and diode that are turn on or sensitive to the light. So ये सब basically हमने पढ़ा था, और this is kind of the IC that is available commercially. So next, technical requirement, जो कि बहुत important है। So what are the requirements satisfied by the optical isolation? सबसे पहले आइसोलेशन प्रोवाइड करनी चाहिए, उसमें ये तो बेसिक रिक्वायरमेंट है। देन उसके बाद सबसे इंपॉर्टेंट होता है लेवल शिफ्टिंग। सो क्या होता है? द आईसीज आर कनेक्टेड एट अ डिफरेंट वोल्टेज लेवल। डिफरेंट वोल्टेज लेवल मीन्स व्हाट? इनपुट जनरली दिस कम्स फ्रॉम द कंट्रोलर, और वी कैन से डीएसपी। डीएसपी से हमें ऐसा सिग्नल्स मिलते हैं। सो दिस आर जनरली 3.3 to 5 वोल्ट। सो एंड सेकेंडरी signals are generally up to 0 to 15 volts. So हम कह सकते हैं that the level is shifted from 5 volt to 15 volt. But this signal should also provide the power requirement to turn on and turn off the power electronics device. So the same signal we can get by using the either phototransistor or photodiode. Okay, so level shifting हो रही है, and level shifting is important because all our power electronics devices works at the 15 वोल्ट। IGBT and MOSFET वर्क्स एट द 50 वोल्ट, जो कि हमने लास्ट लेक्चर में देखा था कि हाउ द टर्न ऑन वोल्टेज इज 50 वोल्ट और समटाइम द टर्न ऑफ वोल्टेज इज आल्सो -7 वोल्ट्स। देन सेकंड एडवांटेज इज दैट नो हाई करंट इज ड्रॉन एट द इनपुट ऑफ सच ऑप्टिकल आइसोलेशन। ऑप्टिकल आइसोलेशन में क्या होता है? देयर आर नो इनपुट करंट, हाई इनपुट करंट ड्रॉन्स, बिकॉज पावर लेवल ऑफ द कंट्रोल इज वेरी लो। and power level at the power electronics devices is high. So we can say that it provides the high input impedance. High input impedance is provided by this IC. Then what are the limitations? Power requirement and floating power supply requirements for a gate driver cannot be satisfied along with the optical isolation only. So another circuit is required to provide the power requirement, or we can say that to turn on and turn off, we require additional circuits. So there is a need of additional circuits that can provide enough current to charge and discharge the gas capacitor. Charging and discharging of the gate capacitor is directly related to the turning on and turning off of the IGBTs and MOSFETs. So this is the additional circuit. So इस सर्किट को हम जनरली कहते हैं टोटेम पोल. This is called as a totem pole configurations. So we can see there are the two transistors, NPN and PNP transistors, and here we supply the our output from the optocoupler IC. Optocoupler IC से हम यहाँ input देते हैं. So NPN transistor कब on होगा? When the base is high, NPN transistor will be on. उसके बाद PNP transistor on कब होगा? जब base is low. Base is low, then PNP transistor will on. देखते हैं कैसे होता है step by step. So this is your optical isolation. Then this is the output of the optical isolation. Input था control का input था 3.3 to 5 volt. Output में है 15 volt. Again this plus 15 and minus Vs are the auxiliary sources that is required to provide the power to charge the gate capacitor. Okay. So mode 1 में क्या होगा? We will see in two modes. So पहले कहा था NPN will be on when base is high. So first जब high signal जाता है तो base is high, then this will be on. So the supply will charge the gate capacitor. Similarly, when the input is low, so base is low, then lower transistor will be on. So the capacitor will be discharged through this part. The selection of Vs and minus Vs depends upon the type of the IGBT or the rating of the IGBT that you are going to employ in your circuit. So let us see some points. So such configurations are called as the totem pole configuration. Vs and minus Vs are selected according to the requirement of the gate to emitter region, which defined by the gate current requirement. ये सब पॉइंट्स अभी समझेगा जब हम when you revise the last two lectures. So current source and sink ability is provided by the totem pole configuration. Current source means charging of the gate capacitor and sink ability means discharging of the gate capacitor. The power requirement by the gate driver circuit is also satisfied by this configuration. But there is a separate power supply that is required to satisfy the floating power supply requirement. हमने देखा था Vs and minus Vs. This is provided by the separate power supply. Thus, all the 5 requirements of the gate driver circuit are satisfied by the totem pole configuration. So, generally, totem pole configuration ही use होता है up till now. Totem pole configuration के बारे में और एक point, voltage needed to be provided is with respect to emitter. So we need the floating power supply. Floating power supply और floating emitter का concept मैंने last lecture में explain किया था आपको. So there should be facility of providing the floating power supply. So floating power supply हम कैसे कैसे देते हैं? Methods to obtain the floating power supply. First, very simple, we use the isolated DC to DC IC. Then you can create the DC to DC converter using the half bridge configuration or full bridge configuration, जो कि easily my students are also creating this type of configuration. Second year students. Third, bootstrapping method. Then this is the general circuit of the isolated DC to DC power supply. That we can provide. This is the reference point. This is plus VG and this is minus VG. This is the plus VCC. Then specifications means how should be the floating power supply IC. उसके कुछ specifications रहेंगे. So the floating power supply should provide the output current so that it should meet the requirement of IGP. IGP क्या है, क्या concept है? Turn on and turn off characteristics में देखा था IGBT और MOSFET के, उसमें concept दिया है IGP का. So current should be generally greater than IGP. That this current is provided by the floating power supply. Then output voltage. VG should be sufficient to charge the gate capacitor. Input voltage, ripples in output voltage is also very important. So means if your VG is having some ripples, so these ripples may affect the driver circuit. So there can be EMI issues due to the ripples, और these ripples can cause the sudden turn on and turn off. हमें turn on and turn off switch का नहीं करना है, फिर भी switch involuntary turn on and turn off हो रहा है due to these ripples. So we need the ripple free output voltage VG. It is also the concept of coupling capacitor. Input और output के बीच में coupling exist करती है. So this is the parasitic capacitor, और we can say unwanted capacitor. ये capacitor हमें नहीं चाहिए और इसकी वैल्यू जितना कम हो उतना अच्छा है. This is called as the coupling capacitor. Coupling current is an unwanted current. ये जो current है that may decrease the isolation level and increase the EMI interference. VG की इफेक्ट क्या होता है? Means if your VG is like this instead of pure DC, what is the effect? जो कि मैंने briefly discuss किया था. The ripples in VG voltage affect the driver circuit Driver circuit is a sensitive circuit. If driver circuit is faulty, then it may lead to the EMI. IGBT may show the unexpected turn on and turn off due to the EMI. The circuit becomes sensitive to noise. That is why ripples in the voltage should be as stable as possible, means no ripple should be there. VG should be ripple free. So you have to use the very good quality of IC for isolated DC to DC converter. So this is the concept of coupling capacitor. अभी मैंने बताया आपको. There is a coupling between input and output. Parasitic capacitance. This is the unwanted capacitance that is getting created by the IC due to the very close distance between the two voltages. Okay, there are two potentials, high potential, lower potential, that create the unwanted capacitance between them. So कुछ points. There is a coupling between input and output. The coupling should be as low as possible. It led to the common mode current and interferences. There is always a coupling current, and it reduces the isolation level, and it may also lead to the EMI problems. So coupling capacitor should be as low as possible. So जब PCB हम डिजाइन करते हैं तो इस तरह से डिजाइन करते हैं that the coupling capacitor का वैल्यू जो है that should be as low as possible. Then proper selection of DC to DC power supply IC. How we can properly select the DC to DC converter power supply IC for floating power supplies? It depends upon the level of isolation voltage required. For example, 10 kV का चाहिए हमको isolation या 5 kV का चाहिए. If such isolation voltage can be provided by the IC, then we can select such IC. If it fails to provide the isolation for the voltage range for which the IGBT is used, then it won't be useful to require to drive the IGBT. So next lecture में देखेंगे कि what are the key specifications of the gate driver circuit. एक सर्किट स्टडी करेंगे हम. उसके बाद what are the specification, basic specification that is required by the gate driver circuit. I hope आपको लेक्चर पसंद आया है. Please like the video, subscribe the channel. Thank you. See you soon.